Good day, everyone. Thank you all for giving me your attention. I remain Matthew Ocheleka Itodu. We are still on acid-base homeostasis, and at the course of this lecture, I'm going to target the role of kidneys in acid-base balance. The role of kidney in acid-base balance. And so many mechanisms come into play to regulate this process. And so I'm going to be explaining the mechanism one by one. And so before I start, I want to explain some key words for you. You all know that one of the functional units of the kidney we refer to is as what? The nephrons. The nephron is a functional unit of the kidney. And the nephrons is made up of renal tubes. They are made up of renal tubes. In segment of the nephrons, they are renal tubes. And these renal tubes, they are the loop of Heylins, distal convoluted tubes, proximal convoluted tubes, collecting duct of the kidneys. And we also have glomerulus that carry out glomerular filtrations of the kidney. Okay, we have the glomerulus that carry out glomerular filtrations of the kidneys. So now we proceed. This number one mechanism that we are going to target now, we are going to target this mechanism to explain to you what happened to the circulation of blood when it comes to the kidneys. And remember that the circulation of blood, there is excessive waste product circulating in blood. And so the kidney want to filter them out. So this number one mechanism, mechanism number one say that the kidney remove sodium salt of acid formed by the action of bicarbonate on acid from circulation by glomerular filtrations. So when the sodium salt by the action of the kidney, the bicarbonate buffer in this case, as the waste together with the blood come to the kidney and there's filtrations, sodium is removed while bicarbonate is absorbed. But now I'm not going to talk about absorption of bicarbonate by the kidney for now. It will be mechanism number two. Now I'll be targeting how does the kidney remove sodium salt, okay, through the action of bicarbonate buffer in the kidney. Now listen carefully. Now I want you to know that this lumen is the center that acid-base homeostasis happen in the kidney. It happens in the lumens. So, and this lumen is a hollow space or cavities in the renal tubes of the kidneys that contain the electrolyte or solute. When we mean the electrolyte or solute, we are talking about this sodium, hydrogen ion, potassium ion, carbonate ion, all the electrolyte. They are found flowing in the lumens of the kidneys, and that is why we say it is a major site where acid-base homeostasis take place in the kidney. So we move. So in the lumen, this sodium ion is exchanged for hydrogen ion in the process that we call sodium hydrogen antipod system. What it means is that the movement is in opposite direction. That as the sodium is moving out of the lumen, hydrogen is entering the lumen. That look at it now, the hydrogen enter the lumen, whereas sodium enter the tube cells. So we have finished explaining to you mechanism number one, how kidney remove sodium. Now we move to mechanism number two, how does kidney absorb bicarbonate? Now, mechanism number two. Kidney absorb bicarbonate from filtration in form of CO2. Okay, how is it not absorbing bicarbonate directly, instead absorbing CO2? Yes, you understand it as you listen carefully. So in the lumen of the kidney, this bicarbonate HCO3 combined with this hydrogen ion. I know what you are going to say now is that where is this hydrogen ion coming from? Remember, in the lumen of the kidney, in this point, so they move out of the lumen and then hydrogen ions enter the lumen of the kidney from mechanism number 1. So now this carbonate ions now combine with this hydrogen ion to form carbonic acid in the lumen of the kidney. Then in that same lumen of the kidney, it will disintegrate into CO2 and water. Okay, into carbon dioxide and water. So why is it doing like that? The reason being that the luminal membrane is impermeable to this carbonate ion, but is very permeable to CO2, means this carbonate ion cannot pass through the luminal membrane, but CO2 can pass through the luminal membrane. What we are saying is that as the CO2 is going, the CO2 you are seeing, but behind the CO2 is carbonate ions that is coming. That is what happened here. So now this CO2 now diffuse now into renal proximal tubes, means they have moved out of the renal, they are moved out of the luminal membrane into the proximal tube cell, which is now rehydrated by carbonic anhydride, this enzyme, back to what? Carbonic acid at the renal proximal tubes. So this we continue. The bicarbonate ion forms from this dissociation of this carbonic ion in the tube cell, diffuse into the what? Blood plasma. Okay, with what? This sodium ion by simple mechanism. Okay, remember this, that this already has been what? Removed from the kidney, have moved out of the lumen in the mechanism number 1. And then in this case, in this mechanism number 2, now CO2 have carried carbonate ion in disguise already into the proximal tubes to meet with the sodium ions, and so they are moving in the same direction. This is not antiport mechanism again. They move in the same direction, in symport mechanism, into what? Into the blood plasma. So now that they are in blood plasma, now we can say that the kidney have restored alkaline reserve or bicarbonate level of the plasma, to make sure that what? There is nothing like what? The body lacking bicarbonate level, because it's at this process that we can be able to regulate acid-base balance. And so listen carefully as we proceed. We are proceeding. Okay, now we proceed. Mechanism number 3, hydrogen ion excretion. This guide, hydrogen ion excretion, is very important. You all know that hydrogen ions, the more the acidic content of the body, when the body pH is very low, very acidic, more hydrogen ion is formed. Okay, and if it is formed, it needs to be excreted out. That is mechanism number 3. How is it excreted out? Now listen. In the distal tube cells of the kidney, this hydrogen ion is formed by dissociation of the carbonic acid. You are already aware of that. So these hydrogen ions now are exchanged for sodium by antiport system. Okay, antiport system. From where we are coming from, mechanism number 2, in the plasma at the proximal convoluted tubes, we already have our hydrogen ion there, and we have our bicarbonate ion there, which are doing for alkaline reserve. But in this case now, this distal tube cells of the kidney now, this hydrogen ions now that is dissociated from here is exchanged for what? Sodium by antiport, means in opposite. Okay, so and then in the lumen, you already know that this hydrogen ion is already in the lumen. Now this hydrogen ion will combine with this component of phosphate buffer to form this sodium dihydrogen phosphate. which is excreted as such in the urine. So that is the way that you can remove your hydrogen ion out of the body. Okay, the way you can excrete hydrogen ion in urine is by by exchanging this with sodium ion in opposite direction movement. Okay, that as the hydrogen ion is moving out, immediately after dissociation of this carbonic acid is moving out of the distal tubes, the sodium ion is coming inside. Now, as it's moved out here now, after dissociation, it's go to the lumen again. As it go to the lumen again, it combine with this phosphate buffer here. Okay, these are component of phosphate buffer, and then this sodium hydrogen phosphate now will form sodium dihydrogen phosphate, and then they are excreted in urine out of the body. That's why hydrogen is excreted. Okay, now we proceed. Sodium enter the blood along with this. Okay, by simple mechanism. So the sodium now that is exchanged with hydrogen ion now, it will enter along with the carbonate, and the hydrogen ion is excreted now, conserved in the tube. So the pH of the urine become acidic at this stage. Okay, so the final mechanism is the formation and the excretion of your ammonia. Formation and excretion of ammonia is the final mechanism. Now, ammonia is formed in the kidney from glutamine extracted from blood. Glutamine is an amino acid. You all know that. Then this glutamine, through the help of an enzyme, there is an enzyme that we call a glutaminase, who hydrolyze glutamine to ammonia and glutamate. Okay, now this glutamate is also an amino acid. Okay, means the body will retain the glutamate because it's an amino acid needed by the body, but ammonia need to be excreted because ammonia is what? Ammonia need to be excreted. Now this hydrogen ions that is formed from here, this step 3, by the dissociation of this carbonic acid, will now be translocated from the renal tubes here to into the lumen, through the lumen by dependent proton pump is a channel for the translocation. Then the ammonia now form a renal cell now diffuse into the lumen, and then the lumen ammonia now will bind to the hydrogen ion protons, okay, to form ammonium ions, okay, which is maintain the body in a very high acidic content. Then ammonia ion present in the urine will contribute to the acidity of the urine, and so because of that one now, the ammonia need to be excreted. Why is the ammonia need to be excreted? Need to be excreted because it's going to combine with the hydrogen ion at the lumen to form ammonium, which will make the body to retain its high acidic content, which will be dangerous to the body. Thank you for giving me attention. I want you to pass through. We have 4 mechanisms that I use in explain. If you can still remember, I explained to you the mechanism number 1, how sodium is removed at the cost of filtration in the plasma, and then how a bicarbonate is absorbed. Here I have explained to you how through antipore system, how sodium is able to be removed, okay, and then retaining hydrogen proton at the lumen. And then this is just a recap. In number 2, mechanism number 2, I also explained to you how a kidney absorb bicarbonate, okay. So number 3, how hydrogen ion is excreted after dissociation of this hydrogen ion at the distant tubes of the kidney. What happened? Through antipore system, opposite directions. This guy here, hydrogen ion at the lumen combined with this phosphate buffer processes, and then to excrete hydrogen ion, they are excreted in the urine. And then finally I'll talk about formation and excretion of ammonia. with the help of these enzymes, glutamine